Today I want to talk about perfect competition in the ice cream industry. Now, of course, everybody has their own choice of what they think is good for the ice cream industry. Cups versus cones, black raspberry versus vanilla, one scoop versus two. But we're not going to get into all the individual choices within the market. Let's just make some simple assumptions about a single cone. In this chart, we have Albert through Nancy and their maximum price they're willing to pay. And we can chart that out. So the first dot on the left is Nancy's dot at $4.50. And the last dot on the bottom right is actually Ken's dot at $1.50. That's all he's willing to pay for an ice cream cone. And we can chart out the demand curve. It's a very simple way to do that mathematically. And it shows how many sales would be at what price. Now, when talking about ice cream, the reason why I want to talk about it is really I want to talk also about utility, usefulness, or satisfaction. If you want to think of that as how many smiles do you have per ice cream scoop? Well, the first scoop, you might have 50 smiles. You really enjoyed that. It was great. You hadn't had it in a long time. The second scoop is still a desirable scoop. We all love a 2-scoop cone, but it may not be as satisfying as the very first scoop. That is where you get the most satisfaction. And although we also like a 3-scoop sundae, there's nothing said. The third scoop isn't providing the same utility, the same satisfaction, the same amount of smiles as the first scoop would. And in reality, at some point by the 5th or 6th scoop, you're actually feeling worse than you did by adding that extra scoop. So your utility is eventually, your total utility is going down, but we see that in the blue. But what we see in the pink is your marginal utility with each additional scoop. Notice that there's no pink on scoop 1. Why? Because scoop 1 is the first one. Marginal is the incremental. So scoop 2 doesn't quite provide the same satisfaction, but scoop 3 and scoop 4 are perhaps also adding value. But the 5th scoop essentially didn't add any value, and the 6th scoop is actually painful. It's making it worse. The 7th scoop, now you're getting sick. So your utility is actually negative. You notice that the chart has a 0 on the horizontal axis. So that's what marginal utility is. Think of it as the number of smiles, if you will, for each additional scoop. I think we do know what satisfaction is when we see it, but in economics terms, we try to quantify that. Now, let's make some assumptions about the ice cream stand. Let's assume that ice cream is selling at $3 per cone. In a competitive market, you couldn't just raise the price because you feel like it. That's all the market will bear. And let's assume there's some fixed costs, like say you're renting the storefront for $100 a day and you're renting the ice cream machine for $25 a day. That's your fixed cost. No matter how many cones you sell, you're going to be spending $125 guaranteed. Variable costs would include the actual cost of the ice cream and the cone. So we've made an assumption of $1 per cone. We're also assuming $8 for an employee per hour. And just for argument's sake, we're assuming that an employee can't be more productive than 30 cones per hour. That would be scooping 1 cone every 2 minutes. Now, if we were to look at the sales chart and say, in order to sell 15 cones, we have to put in an hour's worth of labor. To get to 30 cones, it's only 1.8 hours of labor. Maybe we're selling a little bit better, a little bit more efficient, whatever. In order to get 45 cones, it took 2.6 hours. So we're actually less than 1 hour for every 15 cones at that point in time. But notice when you get down to 120 cones, it took 8 hours to do that. That's fine. But the 135 cones, to get those additional 15, it took 4 more hours. So instead of being open from, say, noontime till 8 p.m., you're now open from 11 a.m. to 11 p.m. in order to get those additional 15 cones. And think about the next 15 cones from 135 to 150. You might have had to been open an additional 8 hours just for that. So you're open from 7 a.m. to 3 in the morning just to get an additional 15 cones. Now you think about that and you say, why would you be open till 3 in the morning just to get 1 or 2 cones per hour, just so you can get to that 15? Well, obviously it's not worth it for the amount you're paying the employee. And that's exactly what it comes down to. So we have a fixed cost in blue in this chart of $125. So nothing you can do no matter how many cones you sell. The variable cost will change as you sell additional amounts of cones. It's going to go up. Obviously, every time you sell a cone, it costs you money because you had the cost of goods sold, so to speak, is the ice cream and the cone itself, as well as the employee's time to scoop it. So in order to get to that 150, according to our chart, you had to work 20 hours, though you could have quit at 135 hours. I'm sorry, 135 cones at only 12 hours. Now, the average cost per unit, obviously if you had a fixed cost of $125 and you only sold one cone, that would be $125 per cone as an average cost. Well, that goes down quickly. If you sold 10 cones, it might be, or 15 cones, it would be $10 per cone. And it goes on down at some point. But you don't necessarily stop selling when you reach the lowest average cost. Although that sounds logical, you're actually not going to. I'm not all that concerned about average cost, to be honest. I'm concerned about marginal cost. Assuming in this case that the marginal revenue is $3, so we have a flat line. There's nothing we can do about the marginal revenue in a competitive market. We can't make changes to it. And let's not worry about the average cost, but it's the marginal cost, the yellow line. That's the one I'm concerned about. So the marginal cost would be the additional worker and the additional cones and ice cream used to make those cones and then to sell them. So the marginal revenue is always going to be $3. But if the additional cost of making that cone, perhaps the employee had to wait 20 minutes for the next sale to come in. So that's an additional cost just to stay open 20 extra minutes in order to then scoop that ice cream, make that cone. It wouldn't have been worth it. You would have spent more than $3, even though that's all that additional cone was going to bring you was $3. And that's where you see the yellow line crossing the pink line. At that point, the additional revenue is $3 and the additional cost is $3. And at that point, you're going to stop and say, I'm not producing anymore. I'm not going to stay open if the incremental costs are greater than the incremental revenue. Who needs to get more revenue if the cost associated with that more revenue is greater? So at that point, that is the point where you say, I'm done producing. Why produce more if every additional one is going to cost me money? And that's an important part in economics, to understand that marginal revenue equals marginal cost at the point of equilibrium in a competitive market.